Hello everyone, this is Robert and this is my currently non-functioning Prusa XL. I went to use it a few days ago and it just didn't do the thing. So in this video I've got to figure out what's going on with it. I'm going to contact Prusa support, see how that interaction goes, and hopefully get this thing up and running again. I'll cover a lot of different things, fixing it, troubleshooting. How is Prusa support? I've actually never dealt with them, so let's dive into it and get this thing working again. Part of the reason for me making this video is that I wanted to give a little bit of context that every so often something will break and you'll need to fix it. You'll need to be able to troubleshoot it. I also wanted to kind of share my experience with Prusa support because this is the only time I've ever really had an issue, so I kind of wanted to share that experience. And also, if anyone else is having an issue similar, maybe they can use this video as a reference. So please feel free to use the chapters to skip around. So what exactly happened with the XL? Well, I'm out here in the workshop, all my printers are out here, my office is inside, and like so many other people, usually I just hit send to printer after I've sliced something, sends it off to the printer, it does its thing, and then hours later you have a part. Well, I did that and I got a timeout. From time to time, printers will disconnect from your local network, so I thought it was that, so I go out here to the printer and realized it was actually locked up. The knob didn't do anything. It was completely unresponsive. No big deal. Turned it off, turned it back on, rebooted it, and went to start the print. And I noticed something interesting. It was failing at the auto home sequence. And I'll show you that here in a second. But it was failing when it was homing. So I just said, I'll update the firmware. It's been a long time since I've updated the firmware. It's always a good excuse to restart it, update the firmware. Those are always good first steps. So I did that and still had the same issue. So when it goes to auto home, it does this. So something is clearly wrong with the Z-axis. It does this when homing, or if you go to manually jog the Z-axis up or down, and you can't very well start a print without homing or using the Z-axis. So we've got to figure out exactly what's going on with the Z-axis in this thing. So now it's time to start troubleshooting, and some of you might notice that the bed is kind of tilted on this side. That's because I've just been manually testing to see if everything moves freely on the bed, and it does. If I move either side, these are totally free, there's no binding whatsoever. That's obviously the first thing to test. Is there some kind of mechanical issue that is preventing this from running smoothly? And there is not. These screw rods feel perfectly fine. There's nothing binding. They're well greased. Everything's totally good with that. So at this point, I do a little bit of research online, do a little bit of looking, see if anyone else has had some issues. Can't find anything too definitive. So it's time to contact Prusa support. So I take a little video of what happened, basically exactly what you guys just saw, and then I show the error message on the screen down below. Unfortunately, that error message indicates that it's a load cell failure, which is incorrect. That's maybe something that they want to look at. If it can't finish the homing sequence, it automatically goes into there being an issue with the load cell, which has nothing to do with this. It just can't physically move the Z-axis up to the load cell. It's not that the load cell didn't read, but that's another issue. So I've got an issue with the motors, driving the motors, the electronics that drive the motors, or something else, so we need to investigate a little bit further. I emailed Prusa support on a Sunday, so I'm going to give them some time to respond back, but in the meantime, I'm going to start digging into some things. So at this point, I've mostly ruled out any mechanical issues. It's probably something wrong with the motor, the driver, the electronics, something like that. The next step in the chain is to actually test the motors. Most 3D printers use just good old standard stepper motors. The good thing about a stepper motor is it's relatively easy to test. It's made up of two coils. You drive one coil, it moves a step. You drive the other coil, it moves another step, and you go boom, 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 and that's what makes it spin. And depending on the order that you energize the coils is either forward or reverse. We don't really need to do any of that. We can just unplug the leads, put a multimeter on it, and see if the coils have resistance. As long as the coils have some sort of resistance and it's consistent across both motors, they're probably okay. So I took my meter, I did exactly this, and I measured 8 ohms on both of the coils of both motors. Most likely those are probably fine. We don't want to rule it out just yet, but there's no smoking gun. Those look okay. So at this point, I'm pretty much ruling out anything mechanical. The lead screws feel good, the bed feels good, the motors seem okay, they measure the right resistance, all of that looks perfectly fine. I think it's also probably not the wiring, although the wiring on this machine is suboptimal. The wire management really is not my favorite. There's a lot of pinch points and the wires are just going every which way all over the back of the machine, inside the machine. It's most likely not that because we did measure the resistance at the end of the motor lead as it connects into the board, so we would probably have seen some issues there. So I don't think it's that. It was a good idea to go through and check, and I went through and just made sure there was nothing overly pinched or in bad shape, and everything did look fine there. So now we've got to dig into the electronics and see if there's an issue there. And there's a really easy way to do this. So let me flip this around and I'll show you what I did. So here's all the electronics on the back of the XL, and it's very tight and cluttered in there, so it's kind of hard to see. On the very top, this header right here is for the X and Y over there, and the second one down is for the Z axis. So what we can do is we can just disconnect, flip, and we can see if the issue is going to follow the connection, follow the motor, or if it's going to stay. If it stays where it is and the Z axis still has issues, there's probably something mechanical or something with the wiring that we missed. But if it transfers over to the XY gantry, then there you go. It is an issue with the driver. So I'm going to swap these over, spin this back around, and we'll see what happens. So now we've got the X and Y where the Z should be and the Z where the X and Y should be. So if I go into Control, Move Axis, and move the X axis, that should move the Z. Look at that. It's moving up, moving down. Obviously, it's moving at a much slower rate just due to how everything is programmed. And if we do the Y, now the Y is going like that because in a Core XY, one signal is inverted. So yeah, don't worry about any of that. But it's moving the motors just perfectly fine, so no issues with that. Now let's go to move Z. There you go. It is a problem with the motor driver. So let's pull out the Buddy XL board and see what it looks like. So this is the Prusa Buddy XL board. This is kind of the main driver / controller of the printer. There's 3 total boards. There's kind of a backplane board that plugs into this, that connects this with another board, and the other board is where all the connections go. That's what you saw me swap those 2 connectors on. I have no idea why they made this into 3 PCBs. It's kind of more expensive to do it that way, but who knows? This is most likely the culprit. I went through this with my magnifying loupe trying to find any issues or defects, and I couldn't find everything. It all looks perfectly good, especially the driver chips over here. There's not a lot on the back. There's no obvious burn marks. There's no fuses on here. Everything looks fine. One of the ICs probably just died. Over here, we've got the X, the Y, and the Z. I'll give you a second to let that sink in. That is right. There are 2 Z motors on this, and they're using a single channel driver. Now, I don't really know why that is. I am the guy holding a dead one where my printer doesn't work because of it, so I obviously have some opinions. I did read the data sheet and the application notes for this IC, and it is a single driver chip, and it is not recommended to drive more than 1 motor with it. However, this is the Z-axis, which isn't really moving very fast. It doesn't really need much power. It's just kind of moving a little bit up, a little bit down. So maybe they can get away with it. I probably would have liked to seen 2 drivers, 1 for each individual motor, but that's just me holding the dead board that doesn't work. This is a TMC 2103, Trinamic 2103 driver, and I'm suspecting that's dead. Instead of rebuying this whole board, this is about $100, $110, it's $130 on printed solid. I'm just going to try replacing that one IC because that is most likely what happened. Passives don't typically fail. Everything else looks to be shared between the X and the Y, so it's most likely just that chip. It's about $8, so it's worth the effort. So let's go replace that chip. So if you're ordering a replacement IC, there's just a couple little things you need to know before you do so. Get your little handy magnifier, look at it under magnification, find out the model number. If it's scratched off, don't go any further, that's something weird. It will always show what the model is on there, so just look at it under the loop, look on DigiKey or Mouser, and you are good to go. There's a couple things you need to be mindful of though. First off is the package type. Notice how each one of these ICs kind of has a different form factor to it. That is the package type. This happens to be a QFN. If we look at it, you can see it doesn't have leads on the outside like these do and these do. This is a leadless package, which means it's going to be a little bit more challenging to solder. You're not going to be able to use a soldering iron with this. You're going to go with hot air. We will approach that later. So a QFN package, and the other thing that you'll find is you have the model number, then you have some kind of designator after that that is the package type, and then there's usually a designator after that that is the packaging, whether it's in a reel, a tube, a tray, things like that. These we're going to be buying in singles, so we don't really need to worry about that, but just make sure that you look at all those different factors, make sure you get the right package type, and make sure that you're buying these in singles, not, an entire reel of these, because you don't want that. So I placed an order for the appropriate motor driver IC on digikey.com, and I got to wait for that to show up. So while I wait for that to show up, let me try and share my experience with Prusa support. I've filmed this a couple times and it gets very long-winded, so I'm going to try and keep this nice and concise. I contacted them on Sunday, October 13th. That's when I first found out about the issue. I emailed them a video showing that everything moved freely, everything, there was no mechanical binding, but it made that noise and I wasn't able to move the Z-axis. They emailed me 2 days later on the 15th, and their suggestion was to remove the Z-axis motor and lead screw, both of them, and test those outside the machine. Their claim was that it could possibly be unexpected wear on the trapezoidal nut that sits on the print bed. They gave me the tutorial on how to disassemble it, but basically that means is you got to take off the whole heated bed, take off that whole lead screw assembly, pull the motors out from the bottom, and then run it, with them outside of the machine. That is many hours worth of work to test if the motors spin freely. I kind of showed you earlier in this video, there's much easier ways to do that. If the coils have the right resistance, they're probably fine. You can test the wiring based on that. It was a long process to get to the same end result. I emailed them back pretty immediately and said, yeah, I've kind of already tested that. I figured out that it is quite possibly the motor driver. What solutions do I have? This is when I learned that I was 1 month outside the warranty. I purchased the printer a long time ago, and they finally shipped. My delivery on it was September 11th of 2023. This email, the first email I sent to them was October 13th, 2024. So it was 1 month outside of warranty, 1 month and 2 days outside of warranty. They told me I'm outside of warranty. I can just purchase a new buddy board. Thanks for contacting support. Instead of buying a new buddy board, I of course decided to just swap the IC. I might still need to buy a new buddy board, but the IC swap is a little bit cheaper and easier. The board itself cost about $150, let's say, with shipping. So that was a bit disappointing that I have, I think, $4,200 into this, $4,200 US in this machine, and the replacement part is about $150 to me, and it's 1 month outside of the 1 year US warranty. Prusa is supposed to be a brand that just works and supposed to be a workhorse, blah, blah, blah. I don't have that many hours on this machine. So I thought that was kind of surprising. And as soon as I presented them with, my troubleshooting, they're like, oh yeah, totally, Buddy Board, replace it, move on, good. I did have to ask them which one of the chips on there was the Z-axis, because I want to make sure I'm replacing the right one. And when I first emailed them, it was October 13th. And when I finally got the answer as to which chip was the Z-axis, that was October 21st. So it took 8 days, start to finish, to figure out that it was outside of warranty, figured out that they were not going to help me with anything outside of the warranty, which is their right, and which chip was the proper one to replace. Okay, so now it's time to actually replace the motor driver IC and see if that fixes the issue. For replacing this, I'm going to be using my hot air rework station. These are relatively inexpensive, and it's really the only way to do this. This is a QFN package, or a leadless package, which means that it has pads on the underneath side. It doesn't actually have any pins. So you can't use a traditional soldering iron because there's no pins and you can't get the soldering iron to the underneath side. So we're going to have to just blast it with hot air. If you've never done rework with hot air, it's actually pretty magical and pretty easy once you kind of get the hang of it and get some experience with it. The hot air station is pretty inexpensive. I've linked down below to the one that I use. And think of it as just a hot air gun that you have control over the amount of air and also the temperature. You just heat it up, let the solder melt, pull it off, and pretty simple. The only thing that you really need to pay attention to with hot air is you absolutely need to use a lot of flux and just kind of go slow and make sure that the heat is always moving. I like to kind of hold on to the chip with some tweezers, hold it up a little bit off the workbench so that as soon as it breaks free, the board will just kind of fall down a little bit. You don't really want to pry or pull anything because that could pull up a trace. Now that the old chip is off, we need to prepare both the new chip and the pads on the PCB. This is pretty easy. It just takes a little bit of practice. For the bare chip, we're going to flip it over to the back side, add some flux, and then we need to pre-tin the pads on the back. This is completely optional. Not everyone will do it like this, but I found it's just a little bit easier when you're doing this kind of in a home shop, is just to pre-tin all those pads and make sure you have a good connection with the pads on the PCB. And this is really a lot simpler than it seems. All you have to do is load up the tip of your soldering iron with a little bit of solder, add some flux on there, and just swipe it across the pads. You can use a magnifying loupe to look at it, make sure you got all the pads, and we're going to basically do the same thing on the PCB as well. Make sure that there's a decent amount, but not too much solder on both the back of the IC as well as the pads on the PCB, and make sure everything's clean and looks nice. So now that both the chip and the PCB are prepped, I can just take the chip, put it over top of the pads, add a little bit of flux, add some hot air, and it will just reflow into place. These QFNs are a little bit of a pain. With the larger leaded components, they will just kind of suck into place once it starts to reflow. You will see it position itself. The QFNs really don't do that. You kind of have to nudge them with tweezers and kind of nudge them back and forth, and the surface tension of the solder will kind of eventually pull it into place. But because the leads are so small and on the underneath side, it takes a little bit of practice, and sometimes you have to add a little bit more flux, go back with the hot air gun, and just kind of nudge it with the tweezers to make sure it's still moving, and then it will kind of want to go into the place. It really wants the pads on the bottom to suck into the solder on the PCB. As long as you have enough solder on both of them, everything should line up and just kind of fall into place. So once again, I apologize for the video quality in that last segment. I was kind of too focused on getting this reflowed, but it really doesn't look like much. Nothing really happens. It just kind of gets stuck into the board, and that's about it. Here's what it looks like afterwards. We got a little bit of flux residue. That's just the flux burning off. I'm going to use some isopropyl alcohol and a toothbrush, get that cleaned up, and then hopefully we can put it back into the printer and see if that worked. I also went through with my little magnifying loupe and made sure that all of the connections looked good, and they kind of look good. On this side over here, it's really difficult to see because this lug is in the way, but I think everything looks decent. So let's get this cleaned up and back in the printer. In theory, I could probably leave the board all nasty and messy like this, but I do like to clean it up with alcohol. Now, if I was doing this the perfect way, I'd probably throw this into an ultrasonic cleaner with deionized water afterwards, but I don't have any DI on me and I don't have an ultrasonic, so this will be totally fine. The only reason you want to really clean this up is if you had a lot of really tight pitch packages, like if there was a bunch of BGAs or something like that, sometimes this residue can get trapped underneath of it and cause you issues, but for this board and this application, just kind of scrubbing a little bit with some isopropyl alcohol will be perfectly fine. Thankfully, replacing the Buddy board is fairly straightforward because it just kind of slots into place. There's no fasteners. You just kind of need to take off the cover, shove it in. I am kind of surprised at how tight everything is back here. They had a lot of horizontal width. They could have used the whole horizontal width of the back of the printer, but everything is kind of centralized in this tiny little spot in the middle, which makes the wiring really tight. And it's very, very easy to pinch a wire or catch something. And I don't know, just kind of surprised by that design choice. All right, everything's back together. Let's turn this on and see if it worked. It's a good sign that it's booting. Dun, 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 dun. Okay, let's go into control, move axis. I'm going to move the X first. Yeah, that looks good. I'm only doing this because I reconnected things, so. Y-axis. Yeah, that looks good. Okay, moment of truth. Z. Hey, hey. Yeah, it's a little noisy, but let's see. Let's go back to auto home. Yeah, that looks fine. So I think that did it. Let's kind of make sure that this goes through the homing sequence, but it looks like it was just a bad driver IC, which is really, really weird. Hey. Yep, so that's exactly what it is. An $8 chip at retail, which probably costs about $3 in quantity. That is what failed. I'm going to give a final recap. So while I do a sample print with this just to make sure everything works out fine, it's time to talk about the conclusion. And there's really a lot to unpack here. And if you've watched my channel for any length of time, you know that I don't really do any scripts. I just kind of wing it for everything. And I'm going to do that once more with this. In terms of the warranty, I am okay with the fact that they chose to uphold the warranty. You got to draw the line somewhere. 1 month is kind of my company's personal policy that we kind of give a pass, because you never know how long this thing sat in the box before I decide to assemble it. You know, maybe I got it delivered when I was out of town. It took me a couple weeks to get to it. So we generally kind of like to give a pass of, you know, a month or two if it's kind of close enough to the warranty period. But you know what? That's their own internal policy. They can adhere to it. Legally, that's totally fine. You got to draw the line somewhere. So if you want to get your pitchforks down in the comments, go for it. Feel free. I'm not going to join in on that. It is unfortunate that a $4,000 plus printer had such a basic failure within 1 year. That's unfortunate. The thing that gets me most, though, the most important thing to me, is really the lack of troubleshooting and maybe kind of common sense with trying to work through this problem. Disassembling the printer should not be the first step. There's a lot of little investigations you can do, which I showed earlier in this video. Having a customer that's unknown to you, like they don't know who I am. I didn't identify who I was and state, oh, I have a high skill level. Just saying to someone, hey, go ahead and disassemble the printer and test this out. That's kind of dangerous. I think the first step could have been, how many hours are on the printer? Have you been experiencing other issues? Things like that. And another saying that I always have at work, because you know I deal in electronics manufacturing for my job, is you never know when that first support ticket's going to come in that's going to be the first one of a massive issue. And I'm not saying that this is going to be some huge issue that's going to blow up all over the internet and all XLs are going to be dying and dropping from the sky, but if you get a lot more motor drivers in the failure, you need to pay attention to all the details surrounding it so that you are prepared if there is an issue. If they're tracking hardware batches and they can go in and see that, hey, we've had like, 5 or 10 of these die with the chip, you might want to look at the date code of the chip, things like that. There's a whole host of things I'm not going to talk about in this video, but no questions were asked to try and figure out if this is going to end up being a bigger issue for them, which I think is kind of critically important. So overall, my experience with their support was lackluster. I mean, ultimately, I didn't need them for anything. And I know I'm kind of a rare case because I can reflow my own boards, I can swap out an IC, things like that. So my technical level is relatively high, but their troubleshooting really got me nowhere. It's like, oh, a worn trapezoidal nut. Come on, a year in for maybe a couple hundred hours of use, that's just not really going to happen. You would have seen brass dust everywhere. There would have been evidence of that. There was no evidence to suggest or support that. So anyway, I'm not overly thrilled with Prusa's support. I'm not overly thrilled with the reliability of this thing. And it kind of begs the question, what happened? I'm still trying to figure out exactly what happened because I looked at this board under a magnifying loupe. Everything looked fine, and I have a lot of experience looking at boards, like a lot. I've looked at thousands of boards under a loupe. I know manufacturing defects, and there was nothing wrong with it. It was perfectly fine. The chip died. That's all that happened. There's no thermal management on the back of that board. There is no heat sink, there's no heat spreader, there's no fan, there's really no vents on the back of that for, just basic airflow. I'm not sure if it died because of that. It seems weird that there is no heat sink, there is no good airflow, and they're using a single axis driver chip for 2 motors. Those things kind of combined seem like non-ideal situations. But once again, I'm the guy making the video that just had to replace a dead driver chip on a $4,000 printer. So of course I'm going to start asking these questions. So I don't know. Throw your comments down below. I'm really curious to see the comment section on this video because there's kind of a lot to unpack. I haven't really been, oh nice, it's messing up. I really haven't been all that happy with this XL. It's hit and miss. I mean, I don't know if you can see that, but right now, I don't know what's going on. Didn't stick. Who knows? Maybe I have to recalibrate something. Oh, yeah, I probably have to rehome the Z-axis because I moved it manually. Anyway, not a big deal. But in any event, hopefully you got something out of this video. Reflowing is pretty easy. I've got a link down below for the reflow station. It takes a lot of practice. If you just kind of use some, dead boards that you have and practice with it, you can get really, really good with it. And it is a very cheap and easy way to fix stuff. So I spent 15 bucks in total with shipping and everything fixing this thing, and I didn't have to give Prusa any more money and spend the $150 for a new board. So that was pretty cool. But anyway, thanks for watching. I got the XL theoretically going again, and I will see you in the next video. Bye.